So welcome everybody. But I think we lost somebody already here on our end. Where is Peter? Of course, our CEO, but I will wait to see if Peter will join a bit soon. I hope he doesn't have any major technical issues. But welcome to the second CXO series. I'm Garrett Klepper. I'm the event manager here at Cybus. And normally I would like to welcome Peter, our CEO and co-founder now. But he seems to have some technical issues at this point. But I see that he is joining. But maybe I would like to introduce then Dr. Walter Heibey first. Dear Walter, lovely to have you here. Maybe you can tell us a few words about yourself.
Yeah, thank you. But now Peter is there also. So glad to be here. So my name is Walter. I'm a partner at MHP, responsible for, well, basically everything that we do at Porsche in the production context. And but I'm also still working as an architect for all manufacturing related aspects.
Thank you. We're happy to have you. And of course, now Peter is here, our CEO and co-founder. Welcome back, Peter. And today's session is update instead of overhaul. So the future of manufacturing when modern factories run like software. So if you have any questions during the conversation between Peter and Walter, please feel free to ask them or type them in the chat that you will find probably on your side down on the bottom right. We will have a Q&A session at the end of this nice conversation, and we will then hopefully cover all of your questions. But now I will hand over to Peter and Walter. Have fun.
Thank you, Garrett. Hi, Walter. Warm welcome into this CXO session. I'm very, very, very happy to have you here and to talk about this topic today for a multitude of reasons. First of all, Cybus MHP really have quite a history now in partnership. We've completed and delivered multiple projects together. So I'm really excited that finally we have the possibility to talk a little bit about that, even publicly, not only behind those doors. And on the other end, this topic, software-defined manufacturing, is really a topic from my heart, to be honest. When we started Cybus 10 years ago, our original thinking was would be so helpful if a factory would just have an API where it would be easy to just connect, get data out of it, control it remotely. So for the last decade or so, we have been saying on every stage, let's plan and run factories like we plan and run huge scaling software systems. And now finding this exactly in your area of expertise is of course exciting me very much. So maybe we can start this conversation by defining a little bit what we actually mean with that, because of course software, everybody knows what that is, but what does it mean when we say software-defined manufacturing?
So I think let's say, and I fully agree. I think that's the idea behind it is basically to have in a factory context also the scalability that we have with modern software. I mean, I started my career many years ago in software architecture, actually, where it was still basically the classical on-premise systems and the classical ABAP systems that you had primarily. And I think software strongly evolved from that perspective. And now we have unprecedented scalability with the hyperscalers and all these things. But this is not only relevant, let's say, only on the IT side. I think the interesting part is to apply these principles also into, let's say, OT, IT environments in the shop floor. And I think that's the first element. So software defined means, okay, learning from the scalability progression that we've had, let's say, coming from the linear ABAP Fortran codings that we had, COBOL codings for 30, 40 years ago, which I still know, to something that we have today. Of course, we cannot apply everything of that, but let's say some elements of that are applicable. So I think that's one definition of what software defined is. we're very much focusing on that scalability element of modern software. The other element is, and I think there we have to be careful because it is, at the end of the day, we have physical assets, we have machines in that we have to integrate. There it becomes a little bit tricky. Yeah. So how do we do that? But I think there another view on that is basically that, well, on these assets, we have software as well. The PLC coding is also software. And another view of that is basically, let's say, to decouple basically the physical part from the process part as much as possible to have that scalability. Because at the moment, in most cases, the process logic is buried in the machine, and that's a hindrance of that. So another definition of software-defined manufacturing is that decoupling of that the physical side and the, let's say, the software side much more to have scalable approaches, and that that requires some technical building blocks that you establish. That's not an easy thing to do, yeah, but it's something that's what we are aiming at, and where one building block is that communication element, the communication layer, which kind of sets the baseline basically of decoupling these in going further. I think that's basically the more factory specific view that I would have on that.
I like that. I mean, that means we think in architectures, is that right? So we think in, you say physical, which is, when you say physical, that's probably the machines, might be the port.
AGV, exactly. Yeah, exactly. So, and I think they where it becomes really interesting, and I think that's also kind of the consequence of that as well, is that the way that we automate factories is or can be different from how we've done these things in the past, because software is not limited by as if we have access to all these machines, for example, in AGVs, then let's say the ability to orchestrate a manufacturing process is much broader. Yeah, we can do much more things than we can do with classical approaches that are purely about the automation layer. Yeah.
Okay, so that means so we have all these physical assets, machinery, AGVs, maybe the building itself, maybe the energy grid, everything that is basically on premise. And then you say there's this cloud world, right? Which might not be even on the site.
Yes.
It might be at a hyperscaler, maybe at distributed across a multitude of hyperscalers. And then you say decoupling. And decoupling is, I think, I'm a software engineer in my heart as well. So from a software engineering point of view, we think in microservices, right? So how do you achieve decoupling, or why do you say decoupling is such a fundamental difference compared to traditional factory design?
Which is, again, it's the same thing as we had with the spaghetti code of old times. Yeah, there you also had to decouple and basically carve out, let's say, services or microservices to make sure that, let's say, functionality capabilities are even, let's say, are more appropriately, more precisely distributed in the software. And the same thing is here that we're trying to do. Basically, what we are looking at is basically to say, okay, what is it that is in the autonomy of a machine, for example? What can they do? What is their job? And what is, let's say, what needs to be orchestrated across? And sometimes if you don't have a clear understanding of that decoupling, it becomes fuzzy and becomes very difficult. And then it becomes also very difficult to change something. And that these are the, let's say, the experiences that we have from a software perspective, certainly as well, because coding is difficult in that if you don't decouple it properly, that the factory is no different in that. So that's also an element that where we say, okay, let's say by clearly defining, let's say, what is in the responsibility of that individual machine and what is, let's say, cross-functional, what is orchestrated, that clear understanding is, again, an architecture perspective that enables, a better orchestration in a broader sense. Yeah.
I think so. Also to make it a little bit more tangible for our audience, we probably should step a bit away from the theory into practice. And I'm very, very happy. I think we had that in our previous discussion as well. timing is quite excellent because we are today able to talk about one really successful example of a factory that was built with software-defined manufacturing in mind, right? Can you walk us through a little bit?
Yeah, exactly. So basically, this is it's a subsidiary of Porsche, the joint venture between Porsche and Walter. The company is called V4Smart. V4Smart is producing round cells in Nördlingen in Germany, and we let's say together with let's say V4Smart, Porsche Werkzeugbau, and MHP, we established that that factory. And there's no paper in that factory. Yeah, everything is digital. And there we, which is kind of interesting because I did 10, 15 years ago when I started with the MES journey, paperless manufacturing was one of the leitmotif there. So that was the one thing that we wanted to achieve. And yes, finally, after some years, we're actually getting there. But actually, the reality is you need to do something like software-defined manufacturing, really get there, because you need that ability to have that, that broader orchestration capability. And today we have the technology for that. And for V4Smart, it was speed was everything, because we had, let's say, the founding of the company was somewhere in March. We had the start of production somewhere in April. When we started this somewhere mid last year, we simply didn't have much time, and so we had to really accelerate what we do. And our clear understanding, common understanding was that the only way that we can do that is with a software-defined manufacturing approach and with a cloud-only approach. There's another element to it, which is, let's say, the more operational aspect that, it's a small company. We cannot, we don't have a huge staff there for IT. So we need to have something that is that can be operated easily. And there again, the hyperscalers with their operational benefits that they have, managed services and such things, it just give you an unprecedented lever in that regard. That was the other reason why we chose that path. But speed was the primary thing we needed to be able to start the production as soon as possible, and we managed with that approach. Yeah.
How fast was that?
So basically, it was something about 10 months in total that we have, but actually, in reality, the timeline was even more compressed because some steps had to be taken first, and before so we started this before the company was even legally founded. Obviously, as a joint venture, that's how you do these things, and basically then went live with the production in April. And I've since then been ramping up, and it's yes, we are good there. Yeah,
I think that's amazing. And just to repeat that, everybody's always talking about this China speed, and then they say, but we in Germany are not able to build factories anymore, or we take way too long, or battery industry in Germany, forget it, nothing happens. I think it's really worthwhile mentioning that this is an example that proves that it's possible, even with the established companies. I mean, Porsche is not a startup; it's very established. But just by taking the right approaches and probably a leap of faith and daring with the right pragmatism, doing something completely new, right?
So, I would agree. I think it is possible to work at that pace. You have to make the right decisions. Obviously, it's in hindsight. Obviously, we took some right decisions, which we didn't know when we started. It's also part of the journey that you have some vagueness and uncertainty, which you just have to manage. And I think this is something where, in many cases, we have, let's say, forgotten how to do this. But if you pick that up again, that entrepreneurial spirit again, then I think it's quite well possible to make that, to be daring and to go ahead. And I think this is what we jointly there were able to accomplish. Yeah, I agree. Yeah. And China speed is that's not a myth. It's something we can do as well. But of course, then you need to take some decisions. And one decision was clearly that we would go for what we call a greenfield approach. So basically, we started everything from scratch, and basically did a complete redesign based on the available technology today. So there was no room for experimentation. So we had to go with what was proven technology today, so that we were not able to take any risks. So we only chose, let's say, available and proven technologies. But with that, we were able to do a software-defined manufacturing, cloud-based only. So the architecture is fully cloud-based. And so I think that proves that it is possible to do that. And then you get that speed element in there, which is quite a surprising, let's say, element. Yeah.
When you sell that, I mean, when this is all IT language, right? And the very technical vocabulary that we use here, cloud and decoupling and so on. But I mean, in the end, we have to convince a production manager, a COO, somebody responsible for the output of the line. How would you? What's your experience? How would you argue to those very pragmatic people responsible for producing? How would you summarize big benefits for them?
I think there's no alternative. I think and that is something you have to explain to them, because as I said, there's no paper in this factory, so there's without an appropriate IT solution on top of it, this factory won't run. So basically what we did is we created, at the same time as the physical factory was being set up, we created a digital factory in parallel to that. And it went live exactly at the same time. And I think this was in that, let's say broadness, certainly something that we haven't done that much often as well, because sometimes in most cases, you don't have a greenfield. You start with something that is where the company is already there for, I don't know how many years, and the ERP system is already there. And, let's say many things, and some of the building infrastructure has also been, some of the machines have already been there. And so the starting point is usually much more difficult. That makes it difficult then to unravel that, and then speed becomes a problem. But if you go for a greenfield, then it's different. Then you can go for what is the most reasonable thing to do without making any experiments, but still trying to find the right path to be able to have that speed. Yeah.
I understand no paper. What else? When I just, let's say I'm a visitor in Nördlingen in this B4 Smart site. What else would be the difference between this factory and any other one? I mean, what would be notable, probably from the software perspective?
I think what is most notable is, and I think there's an interesting story to it, that when you go down now to the factory lines, what you see is you have dashboards of the data of the line running there. And those dashboards were there, let's say, a week after, or some of these, not all of them, some of them were there a week after the start of production. And today, the manufacturing guys, and coming back to your question, how do I convince people of the necessity to do so? It is that you have that availability. You can manage and control your production process based on data. And that gives you precision, that gives you clarity to make decisions. And that ultimately is what production managers want. They want to be able to make their let's say, to influence their let's say, decision-making based on facts, not on assumptions and something that somebody has carried, let's say, some data that manually was written down somewhere. That might be quite lean to do that. But at the end of the day, it's not modern, because in that high volume of production that we have there, it's just not feasible in that approach. And that means that if you want to be at scale with your production, you need data to do that, to, let's say, to manage the volume, but also in particular the quality. And quality constraints, obviously, with battery cells are quite high. Yeah, from a regulatory perspective, and it's quite a high demand on on data quality, which is interesting because some of the things I told you that we set up this digital factory in parallel to the physical factory. Basically, what we have is that we collect quite a lot of data per battery cell, and so thousands of data points per battery cell that we're collecting. And we have a logic or an approach that we are taking that we say, okay, a cell, we monitor the data quality of each of these cells as much as we monitor the physical quality of the cells. So if data is missing, critical data is missing of the battery cell will be physically scrapped. So that means that equivalence of digital and physical factory is really quite unprecedented. But here it's really change also a consequence of what we're doing, that you come to the point that that digital element is as important as the physical element, because you control your volume, your speed, the throughput, the quality of the day of your battery cells, and your legal or regulatory obligation that you have. You fulfill that with that data. If that data is missing, and the cell is basically scrapped. So we have to make sure that all the data that we get from the machine is always there. And if it is not there because we have a hiccup somewhere in the machine or on the communication, okay, then the cell is scrapped. We cannot deliver this cell. And that's quite I think quite an evolutionary step to come to that point. Yeah.
Yeah, I mean, when I listen to you, I noticed a few things, and because I have so many conversations about digitization and manufacturing, and usually, I mean, what you're describing could be called a digital twin, right? But when people talk about the digital twin, this is often a nice to have, a bonus, something. I have this line running, and then I have this digital twin, and I can do simulations and so. But when I listen to you, this digital twin seems to be the core.
Yes.
It's not an add-on. It is the core of the production process. Is that right?
Exactly. As I said, there's a full equivalence of the physical and the digital world in that sense. The digital twin is not just something that is bolt on or something that you can do on top. No, if you want to be able to, or let's put it like this, having that allows you to control your production in a way that otherwise would not be possible. So it is not nice to have. So it's a prerequisite basically to achieve that at the speed in the ramp up. That's what we talked about already. The quality the constraints of the volume, all these things, you need to be able to control that based on data. And the data is in the digital world, obviously, in the digital twin. Yeah.
Maybe I can ask you to challenge me, because when I'm on stage, and I will always have this slide. It says modern factories are run like software, and I have three aspects and examples what I mean with that. One is, and I would be curious if you would agree with that, what I say. One is continuous innovation. What does that mean? I usually say 10, 15 years ago, we all were used to updating software, downloading a new version of a program we have. Set up Excel, double click, you continue. And then once a year, we have a new version of a software. Nowadays, when I have my smartphone, I never install an update for an app, but every day an app might be a little bit different. A small functionality has changed, a color has changed, a button is moving, and without usually it's not even noticeable. Sometimes it breaks and it's getting worse, but then on the next day it's already fixed. And I think this is a major achievement of software today, that we have moved away from huge updates once a year to tiny improvements, probably multiple times per day. And I argue, when we achieve true software-defined manufacturing, this is a continuous innovation pace that we can even achieve within the factory, where we usually don't dare huge IT overhauls, except when the production is interrupted anyway, right? Would you agree with that?
with some constraints, because you have the physical constraints of let's say on the physical side, and we also always have to think of that physical part of the counterpart, the physical counterpart of the digital one. And there we have some constraints. You have to, with operators on the shop floor, you sometimes have to be careful. You cannot just move a button because they might be lost, and then you need to be. You cannot. It's a difference between, I don't know, an Amazon web shop where something looks slightly different there. People will manage, that's fine. But an operator on the shop floor might for that situation, you have to be a little bit more careful with that. That's one element. Or more generally, the impact on the process, you need to be very clear, because otherwise you might interfere and stop production. So the operational risk is something you have to bear in mind. On the other hand, clearly, let's say in what it is as you described, because we have to, let's say, in many cases also have physical changes that need to be done, because, I don't know, a material supply needs to be changed, a scanner has to be introduced there, because we suddenly realize, okay, the material supply process needs to be slightly different, and I don't know. And the ability to be able to change that in alignment of the digital and the physical world, yes, that is something that we can do much more quickly now in these approaches. Whether it is really in such a very small incremental one, here I think always need to look at the process. What is the impact on that? You need to align with that. But yes, it's the same, because the need for the change comes from an optimization of these processes. And so the business is very much interested in that ability to make that change as quickly as possible, as providing it can be done in a stable way. So that's definitely the ability to change, let's say, and also improve also the manufacturing processes, logistical processes, whatever, in conjunction with that, is definitely something that the business does want, because they need to constantly adapt and improve, in particular in domains like battery manufacturing, where it's not factories that have been running for 20 years. Yeah, so it's a different story there.
So ability to change, that's an extremely important keyword. I think really setting up the technology, but probably also the processes and the way people interact with each other in order to facilitate change and make change cheap, and reducing the risk.
Absolutely, because that's exactly when that decoupling that we spoke about earlier does not happen, then every change is very cumbersome and expensive here. Then with that modular decoupled approach, it is more manageable. Yeah, it's still a challenge, but it becomes more manageable.
I think I would briefly, Garrett, before you probably jump to the question, I need to touch one last topic, and that is people. Because does it mean that the CIO is now running the factory, or how are responsibilities and roles split in this software-defined manufacturing world?
Well, I think there is quite clearly so that let's say, and that's actually, it's a strong element of what we are working on. There is let's say, that allocation of roles and responsibilities. I think what changes is that the CIO is kind of on eye level then with the counterparts on, obviously, on the business side. However, the CIO does not own the digital factory. He only provides the fundament of that. Yeah. And then it is the business that owns the digital factory, basically. And they need to take accountability and responsibility for the digital part as much as they do for the physical part. So that is not that clear cut. So the CIO is basically providing the capabilities, yes, the baseline, but the digital processes, the digital twin, the data and such things, they're the business. And here, the example of these dashboards at the light, they were built by the business. So basically, the business had the capability to do these things, and they put them there. So what the CIO did was basically to provide the access to a lake house, to Grafana and whatever, to do the visualization, the technical elements, yes. But doing and putting the dashboard there and the monitor there, that was the business, and purely the business decision. And that's how it has to be, because you need to have The business needs to take over the accountability of that digital factory in the same way as they are responsible for the physical.
Okay, thank you, Garrett.
All right, thanks. Lots of great insights here. So we jump right into the questions that we have here. So we will consecutively go through those questions. We had one at 11:09. So I think that was right at the beginning of the definition of the software-defined manufacturing. So if you look here at the question, some prerequisites might be simplification and standardization. What are your thoughts? Can you?
Yeah, it's implicit. Actually, software-defined manufacturing is all about managing complexity. Yes. And standardization is one way of achieving that, definitely. However, you have to be realistic. Some of these standards are still quite emerging. In there, yeah, it's like with all the standards, it's kind of jumping the bandwagon until it has the certain maturity, so that it actually a standard is a standard. But yes, the prerequisites are as you described. Yeah, we need some simplicity in there because it is about managing the complexity. Because it is complex. Let's say orchestrating a full factory on the digital world. Again, here it was a greenfield approach which allowed us to reduce that complexity and let's say not create a beast, but rather something that is rather tried to, let's say, only have those elements that we actually really need. Yeah, so I agree. Yeah, standardization and simplification are prerequisites.
I'd love to add on to that because that's a great question. And we also have, I mean, this is one really great greenfield project, but we are doing similar projects also in brownfield transformations.
Of course.
And decoupling is the core theme, and decoupling only works if the interfaces are standardized.
Sure.
And you start to basically define the interfaces, and you have to simplify them. So they probably you have to even make compromises. It's so standardization always comes with trade-offs, of course. But you will need to define a common data model that is not use case specific on the one hand, but on the other hand allows all different types of use cases. Just to give some example, Walter, you've said a lot about data of the cells. This is basically data of the product. But of course, in the fully smart factory, you also have your maintenance processes. So you also need data of the asset, or you have organizational things, or the connected worker, or the energy and the carbon footprint and so on. So there's so much you need to standardize in a more or less generic data model. And then you basically, from a decoupling point of view, as you say, we like to say we decouple the problem of getting the data from the shop floor from the problem of what to do with the data.
Yes.
So in the best case, the machine shouldn't know where the data is used because that gives you the flexibility, and the standardization needs to be in the interface.
We just got to catch up here. A question from the same person. So what about processes and services?
Well, let's say, yeah, standardization there would be good, but it really depends on what in particular in the let's say manufacturing domain. We have, in this case, for example, the manufacturing processes were quite different. You have the, let's say, an automated assembly process. That is what we're working on. But the electrode manufacturing process is a roll-to-roll process. So physically, it's a different kind of process, different elements in there. So sometimes you have only an ability to have a domain-specific, let's say, standardization there. Yeah, that is definitely depends on the manufacturing technology that is being used. But in there, of course, you try to reuse, because standardization means the ability to reuse and easily deploy these things again and again. That's a scalability and a cost efficiency element in there. Of course, you are aiming to have as much of that as possible. But then, and that's always the problem, let's say the physical detail when, let's say, delivering something to a machine, then the physical reality might make deviation from the standard necessary, because just there you have a slightly different setup and that needs to be managed slightly differently. So that's kind of the point, the limit of that we have. You have to always to be able to adapt to the physical reality that you are confronted with, that limits somehow the ability of standardization that we have on top. But a proper decoupling will help you with that, because in that sense, for example, let's say decouple logic, Peter, as you described, and then it doesn't. The specifics of the machine should not be visible to the process. Then you can scale and standardize these processes.
I think what needs to be really standardized from a process point of view is governance. So let's say, because we are thinking about service-oriented architectures, right? And every part of the business, be it production or the maintenance or whatever, or the quality control, has their own processes and requirements. But when they need to integrate into this holistic system, it needs to be managed. Which data needs to get from where to where, who has access to which data, and so on. And I think this standardization of governance, decision processes, and change processes, as in software development, in the different rituals or what you have, is essential. So standardize the core to be able to have the individuality in the different business units that you need in order to perform most efficiently.
Yeah, absolutely. So that is a let's say there is a strong transformational element in there for such factories, because organizations need to adapt to that. Let's say the specifics of the digital factory. Yeah, that's definitely something that we are working on.
Okay, then jumping into the V4 Smart Factory part, we had a question coming up with on LinkedIn. We've already seen some insights into the ways of working, Walter. How many people did you implement the project?
Let's say you should ask that the project manager. I'm only the architect. Let's say it was quite a large number that we had, because this was due to the compressed time that we have. And bear in mind, it was greenfield, so we had ERP, MES, shop floor connectivity. We had the Cybus, we had the lakehouse, some infrastructure elements, all these cloud infrastructure elements, all these things that you need for this. So all processes from finance to quality to production, they had to be implemented. So it was quite a big team, I would say. I wouldn't want to shout out the numbers, but let's say it was a big team.
And going forward, will Porsche implement the system at another location as well? For example, at locations in brownfield environment?
Well, in general, I think the pattern of software-defined manufacturing. I mean, we worked with the Porsche architects on this, so it's in clear alignment with what their strategy is. I cannot speculate for what Porsche will do, but I would assume that the general principles of a software-defined manufacturing, that is definitely something that Porsche is, let's say, aiming at also for the brownfields. Yes, but as Peter described, it more convoluted, more difficult there, because you have to work on the there of existing machines without, let's say, endangering existing processes. That's the challenge that we have. Yeah.
I think I would go a bit further, Walter, if you allow, because I think parts of what we've done at V4 Smart was actually invented in Porsche brownfield environments, right? So I think, as you said, at one point, a proven tech stack was the choice. So this was not an experiment, but it was basically a technology stack, and even a team that knew this technology stack inside out, which was established at a greenfield line. So greenfield doesn't always mean new factory. Greenfield can also be one new production line that is established. And I think they started this also public with the same technology stack already 4 years ago on one line. And this is now scattering to this brownfield. So the intralogistics are now also software defined and so on. So
the cloud-based approach is clearly within the strategy of Porsche. Clearly, that is let's say going forward, what Porsche clearly is aiming at. Yeah.
Okay, so last question so far. If anybody feels free, they can still write in the comments, but many questions in this one. So who is responsible when data is missing of a cell? Also managing a digital factory in parallel seems like much effort. How is the organizational setup and how many people manage those digital operations?
Again, I will not shout out numbers, in particular not for smart. I think that was not appropriate, but let's put it like this. Start with the first question. Who's responsible for data is missing? I think that is something, let's say there we have you have to define who is the data owner, who's the process owner, who is the IT owner, who's the asset owner. These things have to be clearly allocated. And then basically the situation is always like this. Okay, the data owner then defines the data, what is being collected. The asset owner is the one who's, from a machine perspective, is then the one who's providing that data. But then it goes through different IT layers. That's the IT owner then who's then responsible to make sure that it then ends up, for example, in the data lake or the lake house that we have. So it's a distributed responsibility that we have, and in reality, you always have to check everywhere in the chain what is the point. Is there a hiccup somewhere, or is it the machine that has a problem? It might vary the reasons for missing data. What's more important, I think, in the first step is to have that, let's say, to monitor that and to make sure that the automatically, basically, the cell is marked as a non-conformance if data is missing, and then it is up to the quality to make a usage decision, basically how to deal with that. Now, is it okay to ship to the customer or not? That's the quality that makes that final shout on what to do with the data.
I think this also pays into the question of governance.
Absolutely.
Because only when you have a well-structured data governance system, like you just described, you can actually understand the relationships between different systems. So which system is probably has failed if a certain type of data is missing, in order to have a quick resolution of this problem, right? This is something that we see in many existing factories as a huge problem, because often, I mean, every factory somehow works with data and has dashboards and so on. IT is everywhere, but often the systems are grown.
Yeah.
And it has become too easy to connect. Yeah, you only need a Raspberry Pi and Node-RED, and you can connect the machine to the cloud. Yeah, but if you don't have a central control about this data orchestration, then it's really, really hard to drill down problems. And as you rely on data as much as Be4Smart is doing that, you really need to retain the control about the data and the data flows.
But to answer some of the other questions there, for example, what is the managing the digital factory in parallel? Yes, of course, it is an additional accountability that you have, and that is something for some. It is part of the transformation to learn that they have that not only for the physical product or the asset they are responsible, but also for, let's say, looking at the data and understanding the data, maintaining master data, for example, for processes and things. It's just a normal accountability, which is actually, when you look at it, not with that uncommon. I mean, we've been doing that for many, many years on ERP side. Yeah, so we are more extending it basically down to the shop floor as well. So I would not say that it is a vast amount of additional effort. It's just something you need to clearly allocate the things, because what you gain out of it is an efficiency that allows you to make to run your processes much more efficient than if you were to do that manually. So that's the point exactly. So then in sum, it's actually a reduction because you have much more efficient processes that you would otherwise normally have. In this case, it wouldn't even run manually, basically. Yeah, you wouldn't be able to carry this amount of stuff around the factory. So it has to be fully automated.
Great. I think that's it. We have got no more further questions. If there are any further questions from the delegate side afterwards, please feel free, of course, to reach out to us. And just a little reminder, if anybody is attending the SPS exhibition, maybe end of November, you can also join us in person on site in Hall 5. Come by the Cybus booth and we can talk about this success story, of course, and other stories with you in person. And at this point, thank you again, Walter, for participating. It was a pleasure having you today. Thank you, Peter, for taking time and go through this success story with Walter. It was a great story to hear, and hope that many stories will follow. Thank you very much.
Thank you.